So this is all over sine A plus another sine A over cos A. Right? Can you pay attention? Can you pay attention? Can you put your phone away, please? Right? Then this will give us sine A times cos A because the LCD is cos A. The LCD is cos A. Right? So this will be sine A cos A minus sine A all over cosine of A. So I'll say divided by, for the denominator I'll also get sine A times cos A, okay, plus sine A all over cosine of A. Okay? So when you do that division, are you following? Right? So let's convert that division to multiplication. Okay? Let's convert the division to what? To multiplication. So that will give me, I'll get sine A times cos A, right? Minus sine A over cos A times cosine of A divided by sine A times cos A. So this will be sine A times cos A plus sine A. Right? So the cos A's are going to cancel out. So we can end up having sine A times cos A minus sine A. This is all over. Oh, okay. Sorry, I put the bracket here. So that's sine A cos A minus sine A. These two will cancel out. This will be all over sine A times cos A plus sine A. All right. Now, huh? Okay, then from here now, remember, what's the objective? The objective is to get cos 2a minus 1 in the numerator, and the denominator has got that 2. So what you can do, when you get to this point here, you can multiply, can I have your attention? We can convert this sine A cos A. I'm sure you can see that it looks like the sine theta cos theta without the 2. You see that? Therefore, we can write this as 2 sine A cos A over 2 minus sine A all over 2 sine A cos A all over 2 minus sine A. Oh, sorry. Huh? I'm not done. The bell rang, so I'll carry on tomorrow. Huh? Was in school. I think around 12. Listen, can I be attention? How many of you didn't get the copy of this paper? Common paper. Where were you when I gave it? Yeah, then it means you decided to go without checking. Alright, can you check this?
Oh my god! That's like
Can you stop the Right, can you stand up? Why are you eating in my lesson? Alright, good morning everyone. I teach there's no one called Panda. Yeah, but there's no one by the name of Panda in that class.
She's not in it.
For me, it's what? Alright, can you sit down please? Alright, yesterday, can I have your attention? Can I have your attention, please? Can I have your attention? Alright, so yesterday I didn't finish going over the homework. Right? So the next question is supposed to be question 10. Right? So if you did the question, right? Please, I want you to be aware that the way that I'm going to do it is not the only way. Okay? It's not the only way. So here, identities they come. Can I have your attention, please? That there are different types of identities. Some identities are easy to prove, others are slightly more complex. So this is like a slightly more complex one. Okay? So I decided to simplify the left-hand side. Okay? It might be possible to simplify the right-hand side until you get the left, but I can see that the left-hand side is a little bit easier. Therefore, this is how I started. Can I have your attention? So we have got our left-hand side. Okay, I converted tan to sine over cos. Then I converted the tan to sine over cos as well. Right? I converted this division line here, this line. I converted it to a division sign. Okay? Then from there now, convert the division sign to multiplication. Okay, then but we did the question. Are you able to get it? Okay. Then we simplify there. Can you stop it, please? Be part of the lesson. So after what I did there, see what I did there. Okay, converting tan to sine, because if you look at the right hand side, doesn't have what? It doesn't have tan. So it means we have to eliminate the tan. And the only way that you can eliminate the tan is to introduce sine over what? Over cos. Okay? Are you following? Then Yeah, the cos A and the cos A cancel out, you get here now. Alright? Then, I'm sure you can see that this, okay, it looks like, okay, it looks like the first part here. Okay, looks like the first part there. So what that means is I can easily introduce the 2. So I can write this as 2 sine A cos A over 2 minus sine A. Right? And then the denominator, I'll do the same. Okay? Then I need to find, and please be aware that this is the numerator. So there's an LCD there. And this is also a denominator. And we need to find its LCD. Right? So, okay. Alright. Can I have your attention? Can I have your attention? You know something? To me, it doesn't make any sense that the teacher is going over a question that you were given an opportunity to do, you couldn't do it. Right? The teacher is going over the question, some of you are not paying attention. Can you close the window then? Just close it. I think it's the other one. Right? It doesn't make any sense. Okay, allow me to carry on. Right? Did I give you another question besides? What? B2. B2. Can you stop? Okay. Can I have your attention? Can I have your attention? Okay. You two from next time you will. Okay. Can you allow me to carry on, please? Hey, can you pay attention? All right. Now, to carry on here, it's much better to simplify the left-hand side. Okay? So, I can say my left-hand side is equal to 2 sine theta, okay? 2 sine theta times cos theta. Okay? That's how I'm going to start. Then, my denominator, well, because I've got this 2 sine theta here, I've got that cos 2 theta. What it means is I might need to simplify the cos 2 theta so that I get this. Okay? But now the thing is, the denominator there on the right hand side, it has got cos. Okay? We have got a cos here, which means somehow my denominator here, I might need to convert it to a cos. But in the end, we just need to get a cos. So my suggestion here is to use this one here. Okay? Can I have your attention? So that we can have 2 sine theta plus, okay, that one there, it's going to become 1 minus 2 sine theta, okay, squared obviously, okay, then we have got minus 1. Because it's very difficult to work with cos together with this 2 sine theta. Okay? This is a 2 sine theta, and this is a 2 sine squared theta. Listen, can I have your attention? I don't understand why some of you talk a lot when you're supposed to be paying attention. Okay, the reason why I decided to use this double angle here is because I've got this 2 sine theta. How am I going to be able to eliminate it? If I use number 4 here, I'll probably be complicating the question, because I'll end up having 2 trig ratios in the same expression, and that makes things very complicated. Okay? Then we get 2 sine theta times cos theta all over. Now, 1 minus 1 gives me a 0. So I'll end up having 2 sine theta minus 2 sine squared theta. Like that. Then we have a common factor. Okay? We have a common factor. So this becomes 2 sine theta times cos theta all over. Now, well, let me take out 2 sine theta. Okay? So you get 2 sine theta times 1 minus 1 minus sine theta. Okay? Right? Okay, so what this means is that these two will end up cancelling out. Okay? So, can I carry on? Yes. Just, what? Okay. Cos theta over 1 minus sine theta. Okay. Can I have your attention now? What is the objective? The objective is to end up having a cos theta in the denominator. That's the objective. Okay? So what we do again, if we want to end up having a cos theta, we can multiply the numerator, okay, by this denominator. When we multiply this denominator by itself. Okay? So we can end up having cosine of theta divided by 1 minus sine theta times. Now, what I'm going to do, have you ever heard of what's called the conjugate? What? Listen. I'm not talking about chemistry now. Can I have your attention? Can I have your attention? When you did SEDS last year, your grade 11 teacher was supposed to tell you that if you have got A plus square root of B, the conjugate of this, it will be A minus the square root of B. Do you know? So what we can do here, can I have your attention? If we want, because I know that some of you will be saying, how is it going to get 1 plus sine theta in the numerator and the cos theta in the denominator? We just use the what? The conjugate of the denominator. Okay? And that conjugate is going to be times 1 plus sine theta over 1 plus sine theta. Yes, but what is this equal to? 1. Okay? So we will end up getting